There is a particular kind of catastrophe that begins with absolute certainty. Not the catastrophe of the unprepared, not the failure of the careless, not the collapse of the negligent, but the catastrophe of the people who were certain, completely and technically certain, that they had solved the problem, who spent 2 decades and billions of dollars and some of the finest engineering minds their country produced, constructing what they believed was the one structure on Earth that American military power could not touch, who looked at that structure and felt something that is rare for any military organization to feel: genuine, grounded, evidence-based safety, and who were destroyed not despite that certainty, but because of it. Because the shelter they built to survive an American strike was not just found, it was studied for years, in detail that its architects never imagined possible. And on the night the weapons arrived, the United States Air Force did not simply hit Iran's most hardened nuclear facility. They hit it in exactly the right places, in exactly the right sequence, at exactly the right depth, because they knew what was inside that mountain at a level of precision that turned every engineering decision Iran ever made into a targeting coordinate. What I am going to walk you through is not a story about a weapon. It is a story about the catastrophic strategic cost of building your survival on an assumption that your adversary spent 15 years quietly dismantling without you knowing. I have studied underground facility defeat, intelligence-to-strike integration, and the history of hardened target planning extensively. And what I want to make clear before we go any further is this. The reason Iran's nuclear shelter became a trap is not that American weapons got more powerful. That is part of it, but only part. The deeper reason is that every choice Iran made to protect the facility, every engineering decision, every construction methodology, every reinforcement specification was observable, was collected, was analyzed, was modeled, and was ultimately converted into a precision targeting package that exploited the facility's own protective architecture against it. The shelter was the trap. The depth was the kill zone. And the United States knew exactly where to hit because they had been studying the target with extraordinary patience and extraordinary technology for longer than most people understand. Here's what we're going to cover. First, I am going to explain why Iran built what they built and why the logic was sound given what they knew at the time, because you cannot understand the trap without understanding the confidence. Second, I am going to walk you through the specific intelligence architecture that turned Iran's construction project into an American targeting database, and explain the collection systems that most public analysis never discusses. Third, I am going to explain the concept of exploiting a facility's own protective geometry, why the very features Iran built to survive a strike became the features that made precise destruction possible. Fourth, I am going to break down the strike itself and what knowing exactly where to hit actually means in operational terms. The fusing, the sequencing, the aim point geometry that translated years of intelligence into structural collapse. Fifth, I am going to give you the Iranian side of what happened after, what their response pattern tells us about how their leadership is processing a failure at this scale. Sixth, I am going to be honest with you about what we do not yet know, because overconfidence in either direction does not serve you. And seventh, I am going to tell you what it means strategically when the thing you built to protect yourself becomes the thing that defines your vulnerability. Let's begin. To understand why Iran's shelter became a trap, you have to begin with the decision that built it. And you have to extend the same intellectual respect to that decision that the people who eventually defeated it did. Because it was not a foolish decision. It was not miscalculation in the conventional sense. It was the correct response to a genuine military problem, derived from careful analysis of a real historical lesson, executed with technical competence and strategic discipline over 2 decades. The problem Iran identified was simple. American precision conventional air power, as demonstrated in the Gulf War of 1991, could destroy any surface target with a reliability that made surface-based strategic assets functionally indefensible. The GBU-58, a 5,000-pound laser-guided penetrating bomb developed by the United States Air Force in roughly 17 days during that conflict, punched through multiple meters of reinforced concrete with a consistency that eliminated any rational confidence in surface hardening. Iranian military planners did not need a sophisticated analytical framework to understand the implication. If it is above ground, it will be destroyed. The solution was geology. The Kuhe Gazlu mountain near Qom, in the limestone and granite formations of Iran's central plateau, offered what no amount of engineering could construct on the surface: natural rock in quantities that no weapon in the early 2000s American inventory could defeat. Iranian engineers, working under IRGC direction with knowledge drawn from studying Soviet-era underground military construction and their own experience with tunnel warfare during the Iran-Iraq conflict, bored downward with a specific number in mind. That number was the maximum confirmed penetration depth of the most capable available American bunker-busting munitions at the time of construction. They went deeper, not marginally deeper, meaningfully deeper. The centrifuge halls at Fordow were positioned between 80 and 100 meters beneath the surface, inside granite of the type and density that reduces even the most powerful available conventional penetrators to surface nuisances. They reinforced the tunnel walls with multiple layers of high-strength concrete. They built redundant blast doors engineered to survive overpressure events. They designed the facility's internal geometry to break up shock waves before they reached critical equipment. They installed independent power, independent ventilation, independent communications. They built not just a facility, but an argument. A structural, geological, engineering argument that this program would continue regardless of what any adversary decided to do about it. And for roughly 15 years, that argument was correct. Israeli military planners studied Fordow extensively with some of the finest targeting minds in any Western-aligned military, and concluded with technical honesty that the Israeli Air Force had no weapon capable of destroying it. Their F-15 IRAM aircraft, among the most capable strike platforms in the Middle Eastern theater, could carry penetrating munitions, but not penetrating munitions rated for granite at that depth. American planners reached the same conclusion by a different path. The GBU-58 could not reach it. Early generation GBU-57 assessments generated internal debate about whether even that weapon, in available configurations, could reliably achieve full structural collapse of the deepest sections in a single strike. Iran knew this. Their intelligence services tracked the debate. And in knowing it, they felt the specific confidence that comes not from hope or ideology, but from verified engineering margin. They had built it deep enough. The math was on their side. Here is where the trap began to close, slowly and entirely without their awareness. The assumption underneath Iran's confidence was that depth equals invisibility, and invisibility equals protection. If an adversary cannot characterize the interior of a facility, they cannot generate the aim points required for precision destruction. If they cannot generate aim points, even the most powerful penetrating weapon is reduced to a probability problem. You are guessing where the critical nodes are, hoping the detonation couples into the right structure, accepting uncertainty that serious military planning cannot afford. Iran was correct that depth provides protection against undirected destruction. They were catastrophically wrong that depth provides protection against characterization. And the distinction between those two things is the entire story. The National Reconnaissance Office operates a satellite constellation whose current capabilities are among the most tightly held secrets in American national security, but whose general contours can be reasonably understood from the open literature and from the observable history of American targeting success against facilities Iran believed were undetectable. Electro-optical systems capable of centimeter-resolution imaging on favorable collection passes. Synthetic-aperture radar systems operating through weather and darkness, around the clock, generating three-dimensional terrain models with sensitivity to ground motion at the millimeter level. When Iranian construction crews excavated the centrifuge halls at Fordow's operational depth, the mountain above those halls experienced ground settlement, the slow, almost imperceptible compression of rock into a void beneath it. That settlement, measured in fractions of millimeters per year, is detectable by SAR systems that track terrain deformation continuously across collection cycles spanning years. American collection systems were measuring that settlement from orbit while Iranian engineers were still pouring concrete walls below it. The National Geospatial Intelligence Agency, whose name appears in essentially no mainstream coverage of the Iranian nuclear strike, but whose role in what happened cannot be overstated, is the organization responsible for converting raw multi-source collection into actionable three-dimensional models of underground facilities. NGA analysts do not produce overhead photographs. They produce something closer to architectural reconstruction. A model of what exists beneath the surface derived from fusing electro-optical imagery, SAR terrain analysis, seismic data, signals intelligence, measurement and signature intelligence from specialized collection systems, and human intelligence sourced from decades of penetration operations targeting Iranian procurement networks, technical, institutions, and scientific personnel. That fusion process does not produce a guess about what is underground. It produces, over sufficient collection time, a model accurate enough to identify not just that a facility exists and approximately where, but where specific functional nodes, centrifuge arrays, electrical systems, ventilation infrastructure, blast door mechanisms, are positioned within it. That is the difference between knowing a target exists and knowing exactly where to hit it. The Comprehensive Nuclear Test Ban Treaty Organization's international monitoring system deserves specific attention here because it is almost never discussed in coverage of Iran's nuclear infrastructure, and yet it contributed meaningfully to the targeting picture. The IMS seismic network was built to detect clandestine nuclear tests by monitoring ground motion globally at extraordinary sensitivity. 170 seismic stations positioned to provide overlapping coverage of every square kilometer of the Earth's surface, monitored continuously by analysts whose job is to distinguish natural seismicity from man-made events with energy signatures orders of magnitude smaller than nuclear detonations. Those same sensors, processed against multi-source intelligence, can characterize tunnel excavation events, chamber expansion blasting, and sustained heavy industrial vibration at depth. When Iranian engineers extended Fordow's tunnel network in the years after its existence was publicly revealed in 2009, seismic sensors positioned across the monitoring network registered the blasting signatures consistent with controlled excavation in the geological formation near Qom. American analysts cross-correlated those signatures against overhead collection data tracking construction material deliveries, ventilation equipment procurement, power infrastructure expansion, and the communications of IRGC security personnel who were generating signals that NSA collection assets were reading in detail. Each data source narrowed the model. Each collection cycle updated it. Over years of sustained multi-source collection, the model of what existed inside Fordow approached a level of accuracy that Iranian engineers could not have achieved themselves without physically entering and measuring the facility they had built. This is what knowing exactly where to hit means in its operational context. It does not mean that American planners had a general understanding of where the facility was and a weapon powerful enough to damage something in the general vicinity. It means that years of NGA analysis produced a facility model with sufficient fidelity to identify specific aim points, specific locations in the facility's geometry where a weapon detonating at the correct depth would couple its energy into load-bearing structures in a way that produces cascading collapse rather than localized damage. The difference between those two outcomes is not marginal. A deeply buried facility can absorb enormous energy if that energy does not reach the right structural nodes. The same facility, struck at the precise point where load-bearing geometry is most vulnerable, collapses rather than absorbs. Getting to that level of targeting precision is not primarily a weapons engineering problem. It is primarily an intelligence problem. And the intelligence problem was solved, quietly, over a decade and a half, while Iran watched their engineering margin and felt safe. Now I want to explain something that I think is the most underreported dimension of this entire operation. The way Iran's own protective engineering choices created the targeting geometry that defeated them. This is what I mean when I say the shelter became the trap. It is not a metaphor. It is a specific technical reality. When you construct an underground facility at extreme depth inside a granite mountain, the engineering requirements for that facility generate observable signatures and structural constraints that an adversary with sufficient collection capability can exploit. The ventilation system required to sustain thousands of operating centrifuges at depth must move significant volumes of air per minute, and that movement is detectable as a thermal signature at the access point, even when the access infrastructure is hardened and disguised. The power infrastructure required to run enrichment operations at scale creates electromagnetic signatures and requires a physical supply chain, transformers, cables, switching equipment. That must be installed, maintained, and periodically replaced, generating procurement signatures that intelligence collection tracks. The blast door geometry required to protect the deepest sections against overpressure creates specific mechanical constraints on how those sections can be accessed. Constraints that, once understood, tell a targeting analyst where the access corridors are relative to the centrifuge halls, and therefore where an aim point that collapses the corridor physically isolates the hall rather than simply damaging it. Every protective feature generates an observable. Every construction decision creates a constraint. And an adversary that has spent 15 years observing those observables and modeling those constraints does not simply know where the facility is. They know how it breathes. They know how it gets its power. They know where the load-bearing elements are. They know where the access geometry creates structural pinch points. They know which specific aim points, if struck in which specific sequence at which specific depths, will not merely damage the facility, but eliminate its operational function. That knowledge transforms the B-2 sortie carrying the GBU-57 from a very powerful conventional strike into a precision surgical operation against a target that has been studied with the rigor of a building that is being deliberately demolished, where engineers pre-calculate exactly which structural members to remove and in which sequence to achieve controlled collapse rather than random damage. The fuse system on the GBU-57 is what makes that precision physically executable in a way that previous generations of penetrating weapons could not achieve. Earlier bunker-busting munitions, including the GBU-28 and its immediate successors, used relatively simple fuse mechanisms. Delay fuses calibrated to allow penetration before detonation, but without the sophisticated material counting capability required to detonate at a specific depth inside layered geological and construction materials. The GBU 57's fuse hardware was engineered, at significant cost and over a development period measured in years, to survive the deceleration shock of high-velocity impact with granite, count material boundaries as the penetrator drives through alternating layers of rock and reinforced concrete, and time detonation to within a fraction of the penetration sequence that places the explosive energy at the depth and location specified in the pre-planned aim point. That capability converts the facility model NGA developed over 15 years of collection into a specific fuse configuration for a specific weapon against a specific aim point. The intelligence and the weapon become one system, and the system's output is not damage to a facility. It is collapse of a specific structural node at a specific depth identified by 15 years of sustained collection as the point at which the facility's protective geometry fails. What followed the strike in terms of Iranian public response followed a pattern that students of Iranian information operations will recognize from previous incidents, but with some notable variations that carry analytical significance. The initial posture from Iranian state media and official government statements was blanket denial. No significant damage, a fabricated American narrative, the facility intact and operational. This phase lasted a shorter time than in previous analogous incidents, which is itself a data point. The transition to minimization, acknowledging that strikes occurred while disputing their effectiveness, came faster than Iranian communications management protocols have historically produced. Iranian officials began framing the operation in terms of international law violations and regional destabilization rather than maintaining the technical capability denial that characterized the early hours. Senior IRGC commanders, whose public statements on military matters are carefully calibrated for both domestic and external audiences, made references to resumption and rebuilding rather than continuation. A word choice that carries very different meaning and that analysts monitoring Iranian official communications noted immediately. Khamenei's public statement, measured against the baseline of his response patterns to previous Israeli and American military actions, showed what communications analysts describe as compressed formulation time, a shorter period between event and official Supreme Leader response than his pattern suggests for situations where the response can be structured around a confident counter-narrative. None of this constitutes confirmation of facility status. All of it is consistent with a leadership that is managing a significant unexpected failure rather than a manageable external challenge. Before the strategic assessment, I want to be honest with you about what remains genuinely uncertain, because I believe your understanding is better served by calibrated confidence than by false precision. The physical status of the deepest centrifuge infrastructure at Fordow is not yet publicly confirmed with the specificity that the intelligence community's classified assessments will eventually reach. Battle damage assessment on deeply buried targets requires collection cycles, analysis time, and in some cases ground truth information that takes time to develop. Whether Iran successfully dispersed critical centrifuge components or quantities of enriched uranium prior to the strike, a precaution any competent military organization facing escalating threat conditions would execute, is not fully characterized in any publicly available reporting. There are analysts with access to classified assessments who have indicated significant structural damage while noting that questions about specific subsurface compartments remain under active analysis. That is the honest picture. Significant damage, assessment ongoing, full picture not yet public. Now the strategic reality that most coverage has not fully addressed. The trap that Iran's shelter became is not primarily a physical trap, the physical dimension. A facility designed to protect the program now collapsed onto the program, is significant but limited in its long-term strategic meaning. Iran has engineers. Iran has resources. Iran has remaining nuclear infrastructure at other locations. A severely damaged or destroyed Fordow is a serious setback. It is not necessarily a permanent termination. The trap that matters strategically is the epistemological trap. Iran built its entire deterrence posture on a doctrine that said, "We can go underground and you cannot follow us there." That doctrine gave Iranian leadership the confidence to maintain enrichment at levels approaching weapons grade, to sustain proxy forces across the region that raise costs for any military action, to negotiate from a position of structural leverage, knowing that even if negotiations failed and military action followed, the core program would survive in its mountain sanctuary. The doctrine was not merely a military position. It was the foundation of Iranian strategic identity. The answer to the question of how a medium-sized regional power sustains meaningful deterrence against the world's most capable military. Going underground was the answer. The shelter was the answer. And the answer is gone. What replaces it is uncertainty of a kind that is more strategically destabilizing than the external pressure the shelter was built to resist. Iranian leadership knows things they cannot say in public. They know that NGA's collection architecture has been building models of their underground network for years. Not just Fordow, but every facility in the network. They know that the same targeting methodology that converted Fordow's facility model into a precision strike package can be executed against any characterized node in that network. They know that the B-2 penetrated their most capable available air defenses without generating a defensive engagement, which tells them that the IRGC air defense commanders who were responsible for protecting the facility did not have enough warning time to act, and that the same will be true of any future strike against any facility their collection systems cannot hide. And they know that the operational gap between intelligence and destruction, the gap that used to give underground sanctuary its strategic value, has been eliminated at the system level, not just in this specific instance. That knowledge creates what I believe is the most consequential strategic condition to emerge from this entire operation. Iranian leadership must now plan under a fundamental uncertainty they have not faced before. They do not know which of their remaining facilities have been characterized to the level of precision that Fordow was characterized before this strike. They do not know which of their underground nodes are already in an American targeting database with aim points, fuse configurations, and strike package sequencing already developed. They cannot know, because the collection systems doing the characterization are not visible to them. And that uncertainty, the inability to distinguish which facilities are safe from which are already targeted, is functionally equivalent to having no safe facilities at all. You cannot make confident strategic decisions from inside an uncertainty you cannot resolve. You cannot credibly threaten from a position of strength you cannot verify still exists. Every regime that has invested in underground military infrastructure as a deterrence component is now performing the same calculation. North Korea's military planners are not asking whether this changes their doctrine. They are asking how quickly a response can be developed for an adversary that has demonstrated it can find, model, and destroy underground facilities their engineers built to be invisible. Chinese PLA rocket force commanders responsible for the underground Great Wall, the extensive tunnel network designed to protect nuclear systems from American conventional strikes, are gaming force posture adjustments against a demonstrated targeting capability that eliminates the operational assumptions those postures were built on. Russian strategic planners, whose deep command facilities beneath Moscow were engineered to survive near-miss nuclear detonations, are evaluating what it means that conventional precision now reaches depths previously reserved for nuclear effects. The signal traveled instantly. The strategic reassessment it demands will take years. But the reassessment has already begun, in Pyongyang and Beijing and Moscow and every capital where military planners built their confidence on the doctrine of going deep enough to survive. Here is the bottom line. Iran did not simply lose a facility. They lost the architecture of their safety. The shelter they built to make their nuclear program survive American military power was found, characterized, modeled in detail, and struck at the precise locations identified through 15 years of sustained intelligence collection as structurally fatal. The weapons reached depths that Iranian engineers calculated were physically unreachable. The fuse systems detonated at depths specified by targeting intelligence rather than generic penetration tables. The aim points exploited the facility's own protective geometry, the very features built to absorb and deflect blast energy, against the structure they were meant to protect. The shelter became the trap, not because America got lucky or because Iran got careless. It became the trap because the intelligence architecture that characterized it had been running for 15 years before the weapons arrived, and by the time those weapons released, the facility was not an unknown target. It was a known target, fully modeled, with the aim points already calculated and the fuse configurations already specified. Iran built their confidence on the belief that depth means invisibility and invisibility means survival. The United States spent 15 years proving the first half false, and this operation proving the second half false. That is not a military result. That is a strategic transformation. And the world's understanding of what underground now means, as deterrence, as sanctuary, as survival, will never be the same.